Okay, we just covered the lecture material on vectors. This should be somewhat reminiscent of what you've done in Math 119 with matrices. All right, these are either going to be row or column vectors. Typically, we write it down as a row. We talked about magnitude. We talked about the addition of vectors. And we talked about the scalar multiplication of vectors. Basically, just a scaling. We talked about standard vectors. These are basis vectors, I and j. We talked about how to rewrite a vector v as a linear combination of I and j vectors. We talked about their components being related to the trig that we've discussed. It's important you know the trigonometry of these vectors. We derived the formula for the angle between two vectors. It involves something that pops up an awful lot, and that's called a dot product. We also covered that. All right. Now we're going to go to the examples. So let me switch screens. I'm going to plug in my thing here. Just give me a moment. All right. So we're at the examples. We'll start with example number 1, of course. All right. So let's say it says, find the component form of the vector v and the magnitude of that vector as well. All right. So one thing I'd recommend to do is kind of draw it if you can. And I put this down for you, put an axis down for you. And I've got 2 points. The first point, 9/2, comma 0. I'm going to say that's over here somewhere. And then there's a terminal point, which is minus 9/2. I'm sorry, 0 minus 9/2. I want to tell you what this vector looks like. Initial, and then it stops at 1. Look like this. Now, what we have to do is take this vector here and move it to the origin. What I mean by that, we're taking this point here, the initial point, and sliding it over 9/2. If you did that, what would your vector look like? It would look like this. All right. What's this terminal point though now? Well, I'm hoping you can look at that. I know the terminal point here is going to be, well, let's see, we moved it over. What did we move it over? We moved it over 9/2 of units. This is minus 9/2, comma, minus 9/2. All right, that's just moving it around. So let's talk about the component form of the vector is v. I'm going to put a bar in front of it. Minus 9/2, comma, minus 9/2. If you would write that down in the ij form, it would be minus 9/2 of the vector I minus 9/2 of the vector j. All right, now what else did they ask for? They asked for the magnitude of that vector. And we denote this by this notation. And what's that going to be? Well, those components squared. So the first component squared, that's minus 9/2 squared. And the second component squared, minus 9/2 squared. What does this give you? I'm going to write this down. 81/4 plus 81/4. What would this give you? Well, if I did that, I would get 81/2. What does this give me? The square root of 81 is 9 over the square root of 2. I don't mind that answer. I'll put a box on it. Some teachers do. They multiply the top and bottom by root 2. Now we get 9√2 over 2. That's something you did in Math 100. All right. So what did they ask for? They asked for the component form, and they asked for the magnitude. Let's see if we got the right answer. Over here, I see this, and I see this. By the way, approximating, you need a calculator to do that, and I'm hopeful that you're able to use a calculator. But again, if not, come by during office hours, and we can discuss that. It's approximately 6.3 something. Okay, let's go to the next page. And let's talk about number 2. Now, number 2 reminds me of what you did in math 119. This is basically just, adding two matrices together. But again, these are vectors, U and V. So when you add them together, again, it should be relatively simple. I'm going to put this down for you, U plus V. Just add in your components. So 9 plus minus 3 is 6, and 9 plus 0 is 9. Again, look at the key. Whoops, make sure you got that. Let's go to the next one. I need to put a check next to this. Let's go for this. What's this one going to be? Well, I'm not a stickler for detail, but I want to point out this is really an addition problem. It's vector U plus minus 1 times vector V. No, you don't have to do that. But I think I can do it just by looking at it. What are you going to get? 9. It's a scalar multiple of V, so it's 9, and the scalar multiple of minus 1. So it'll be 9 plus 3, which is 12. And then you would have the second component of U, which is 9, minus the second component of V, which is going to be 0, so that's going to be 9. Again, look at your key to make sure you can agree with that. All right, let's put this one down. This is C. I'm going to write down the scalar multiple of U. That's 2 times that. That would be 18, plus the scalar multiple of V, which is going to be 3 times that, which is minus 9, 0. Add them together, what do you get? 9, 18. Right, again, I can't say enough times. Look at the key, make sure you're getting that. All right, let's put this one down. Not so bad. It's 3 times U. That's a scalar multiple, 27, plus, all right, it's minus 2. That's the scalar multiple times the vector V, which would be 6, 0. What does this give me? 33, 27. All right, let's go to the next one. And number 3. All right, so it's find a vector in the direction, find a unit vector. Now, what happens to a lot of students are, they read that and they say, what do you mean unit vector? A unit vector has length 1. If you look at this vector over here, it has length 3. So if you just draw a picture of it, and I'll put that down for you. And that vector is going to be the initial points there. Terminal point is going to be over here. And what's that point? This point over here is minus 3, 0. So the length of that vector is actually 3 units long. So the length of U is 3 units long. Now what they want to do is find a unit vector in the same direction. Well, I'll be honest with you, that couldn't be any easier. And why is that? All I'm going to do is put a vector down here with length 1 that's in that direction, right? So what's that vector going to be? Well, that vector, just looking at it, is going to be, I'll put a box in this, minus 1, 0. All right, let's talk about the formula for this, though. The formula for this is going to be very simple. It's going to be the vector U divided by its length, or magnitude. Let's write that down. That's 1 over length of U. This is the scalar, times U. All right, let's go through this. The length of U is going to be 9 plus 0, the root of that, and the vector U is going to be minus 3, 0. All right, let's keep going through this. What do you get over there? 1/3 minus 3, 0. And what does that give you? Minus 1, 0. Do we get the same result? Of course we do. You can use the formula. And again, what's the formula? This is the formula over here. Okay, let's check our answer. I'm seeing this. I'm seeing this. Let's go to the next question. It should be number 4. Okay, number 4 says, find the vector V with the given magnitude and the same direction as U. Right now, I like to write U, not in this, multiples of I and J, but in component form. So in component form, what is it going to be? It's going to be 9 minus 10. All right. Now, the only thing I know about V, I'll write this down for you, that V has 2 numbers in it. And what are those 2 numbers going to be? Well, I'm going to write down V1, comma, V2. Now, what else do I know about V? I know the length of V is going to be 11, right? Now, the problem comes now is it has the same direction as you. So what I'm going to do is I'm going to write a unitized vector down for you. And let's see if we can do that. So it's going to be 1 over the length of u. All right. And let's see, 9 squared is 81. Minus 10 squared is 100. Times the vector u. What's the vector u? 9 minus 10. Let's write this down. And that's going to be what? 9 over root 181, comma, minus 10 over root 181. Let me just point out what I just said about this thing. This thing over here is a unitized vector, has length 1. This vector has length 1. It's this vector unitized, right? Now that vector's got a length of root 181. This is a unit vector in the same direction. What do I want? I want a vector v whose length is 11, but the same direction as this. It's going to be a scalar multiple. Let me write that down for you. So what's it going to be? V will be 11 times this. And we just did it. And what do you get? I'll write it down for you. 11 times this, it would be 99 over root 181, comma, minus 110, multiplied by 11 over root 181. Put a box in this, look at my answer K, and I'm saying, oh, they put it in component form. Sorry about that. Put that down for you. So what's V going to be? Let's write this down for you. V in component form is going to be 99 over root 181 I vector minus 110 over root 181 vector j. Again, I can't say enough times. Look at your key to make sure you're looking at that. All right. So let's go to the next page. And I just think I finished. Let me just make sure I said I did that right. And I can look at my notes. We did 1, we did 2, we did 3, we did 4. Yeah, we're going to the next page. And we're going to do number 5 now. All right. There's a point to this. And if you see the point immediately, there's no reason to do a bunch of work over here. But right now I'm looking at this and it just doesn't look familiar to me. So I'm going to emphasize that it would be nice to know what the cosine of 120 is. Oops, sorry about that. All right, cosine of 120 degrees. So we have a reference of 60. Right, so it's going to be a half. Minus half, I'm sorry. The sine of 120 degrees is going to be root 3 over 2. And yeah, you should be somewhat familiar with that at this point. Now, if you multiply this out, what would you get? Well, you would get 2 times the cosine of 120 is minus 1/2. That's vector I plus root 3 over 2 vector j. All right. And what would you get over there? Minus I plus root 3 j. I'm going to write that in component form, and that would be minus 1 root 3. Okay? Now, they didn't ask for that. So why would you have done that then? Just so you're familiar with what we're going to ask you to do here. And I got to be honest with you, there's something about the way this is written that may make this problem really easy to do, prevent me from doing all the work I just did. But the first thing I want to do, I want to do the magnitude of the vector v. I'll write that down for you. And what's the magnitude of vector v? Well, look at it. It's going to be the root of minus 1 squared, which would be 1, plus the root 3 squared, which would be 3. And this would give you the root of 4, which is 2. So the magnitude is 2. I want to point out, I'm seeing that number right here. All right, we'll talk about the form later. Let's do direction now. To do direction, I want to draw the picture of it. Oops. And what's that going to be? Minus 1. And then root 3 up. And you should recognize this as being the direction of it. And what's that going to be? 120 degrees. So the direction theta, I'll put this down for you. Oops, go back to black. Theta is going to be 120 degrees. Right, again, this is magnitude. And this is going to be the direction of it. Now, of course, you're looking at that. You see that over here. I want to claim about this one over here, V. There'll be some number here. Let's call it K. Cosine theta I plus sine theta j. I can read this K is going to be the magnitude and theta is going to be the direction. Okay, let's go to number 6 now. Number 6 says, do the dot product. Well, again, I like to write these things in component form. So U, the component form is 2, 3, and V is minus 2, 5. They want the dot product, U dot V. Couldn't be simpler. Multiply their components together. 2 times minus 2 is minus 4, plus 3 times 5 is 15, and that's going to give me 11. That's a dot product. All right, let's go to the next question. Next question over here. It might seem difficult to you, but it has something to do with what we discussed in lecture. And we have 2 vectors. I'll write this down for you. We have vector U, which is, whoops, I mean to do that, S, comma, minus 5. And we have vector V, which is going to be 6, comma, S squared. Now, what do they tell me? They tell me these vectors are orthogonal. What does that mean? They're at right angle. So the angle between U and V is 90 degrees. So cosine of theta is U dot V over length of U, length of V. All right. If the angle theta is 90 degrees, the cosine of theta would be 0. What does this tell me? It tells me that U dot V must be 0. Well, to put that down, you would get 6S minus 5S squared equals 0. Factor out S, you would get 6 minus 5S. And what do you get there? S could be 0, or S could be 6/5. Look at the key. No need to draw a picture. However, if you want to, you can. Well, let's do number 8. And number 8 says find the angle theta between those 2 vectors. All right, so let's write the component form down. And the other one, V, is going to be minus 2, 2. So cosine of theta is going to be equal to U dot V over U, the length of U, times the length of V. Let's get to work. What's U dot V? That's the easy one. That's going to be minus 2, minus 2. What's the length of U? Well, the root of 2. And again, the reason for that is 1 plus 1 is 2. What's the length of V? What do you get there? You get 4 plus 4, which is 8. All right, looks like you're getting pretty easy now. In other words, your arithmetic is really nice. What do you get on top? Minus 4. What do you get on bottom? Root 16, which is 4. What do you get there? Minus 1. All right. Now the question becomes is, what did they ask for? They asked for the angle theta between the vectors. So what does that mean? Theta is going to be equal to arc cosine of -1, which is going to be, again, if you need to review, you go back to do arc functions. This is 180 degrees or pi. Look at the key, and you should be staring at that. Let's go to the next one, which I think we just did 5, 6, 7, 8. I guess we'll do 9. And 9 is right here. All right. So it says use vectors to find the interior angles of the triangle with the given vertices. Now, certainly, I'm going to say some people can do this pretty quickly. Other people take time to do it. Some people may do it differently, but I want to point out, does they use vectors? So my first goal over here is I want to see what the vectors are. Right, I want to see what they are. All right, let's take a look. I'll put the points down for you. And let's see, I'll put down, I don't know, 0, 4 first. And then I'll put down 4, 2. This is just an approximate picture, by the way. And then I'll put down the point -5, 0. I'll draw my triangle in. And I'm going to use vectors. I'll tell you what vector I'm going to do first. I'm going to call this A. I'm going to call this B. And call this C over here. All right. I need to move the triangle so it's in standard position. And I want to do A first. I'm going to put that down over here. I'm going to need something that looks sort of like this over here. I move that in there. What would this be over here, though? And this one over here. I'm going to go over here and put the points down for you. This is -5, 0. This is going to be 4, 2. And this one over here is going to be 0, 4. So what did you do? You moved it to the right 5 units. So what do you have here? 5, 4. You move the point 4, 2 to the right 5 units. What's that going to be? 9, 2. What angle am I doing here? A. Let's write this down now. Well, cosine of A dot product, which can be 45 plus 8. The length, that's going to be 25 and 16, 41. Let's see, 81 and 4, 85. And I'm going to, add it together. Do a little bit of work. I'm not going to do much work. 45 and 8 would be 53. And I'm going to just write down root 41, root 85. Not much I can do about that. What's A going to be equal to? Arc cosine 53 over root 41, root 85. I'm going to use a computer. I'm actually going to go down and look for my calculator. Give me a second to pick it up. And I'm going to just type it in. And what am I typing in? Arc cosine. Let's see, 53 divided by the square root of 41 divided by the square root of 85. You get 26, right? And I'm reading my calculator, 0.13. Okay. All right, let's keep going. And let's take a look at another one. Yeah, so what are you going to do now? Well, I want to point out what I'm going to do. I'm going to take this point here, I want to do B, and move it down. Right, take this point here and move it down. And what about if I did that? And I moved it down to there. right? I would get, two vectors now. I'd get a vector that would look like this, and a vector would look like this over here. All right. Now, what did you move down? You moved down everything down 4 units. So every point's been pushed down 4 units. So what would this vector over here be? Well, I'm just pushing it down, so it's -5, and I pushed it down 4, so that'll be -4. And I pushed the other vector down, right? I pushed it down, and what would it be? I'll put it down. You get what? Well, it's still 4. If I'm 2 and I move down 4, I would be at -2. And what angle is this? This is angle B now. Let's write this down. Cosine of B is equal to arc cosine. Let's see. I'm going to do the dot product. And that's going to be what? I'm sorry. I'm jumping the gun here. I got it backwards. And I really apologize for that. Let me get go backwards on this. I said arc cosine. It's not arc cosine. It's just the u dot v now, which can be -20 and +8. It's not so bad. Now length, that's going to be 25 and 16, 41. That's not so bad. And let's see, 16 plus 4 is 20. And I think I can go the next step. And I think I can write B down now. B is going to be arc cosine. Let's see, that's -12, right? Over root 41, root 20. And yeah, I've got to use a computer to do that. And I'm going to take my handheld calculator. I got one of these ancient calculators. It's actually a TI 89. It looks ancient compared to what's available on your computer. But I'll type it in, arc cosine, -12, divided by the square root of 41. And yeah, you really should learn how to use a computer or a calculator. Square root of 20. Let's see if I typed it in. Oh, I see a problem already. And it's really hard for me to read the calculator right now. All right, so I get a number. And the number I'm getting here is 114.78. Okay. All right. Now, someone says, how you can get the other one? I'm not going to push this thing around anymore. I've already done it twice. I'm going to write C down now. And what's C going to be equal to? 180 degrees minus A minus B. I know A and B. And if I did the arithmetic there, what are you going to get? You can get 39. Oh, there's an approximate over here. Sorry about that. That's it. Thank you.